Hello and welcome to Alchemy of Thoughts, and I'm your host, Dr. Manohar Rao, where we try to simplify science for laymen through storytelling. Recently, we came across a heart-wrenching story, the death of multiple children in MP linked to contaminated cough syrup. But this tragedy is part of a much bigger and global pattern, one that has claimed lives across continents, and one that science and simple testing could have easily prevented. The cause? Diethylene glycol, or DEG, a sweet-tasting but deadly industrial chemical. Reports suggest that a batch of cough syrup contained diethylene glycol was well above permissible limits. Samples from contaminated brands were found to have DEG in almost 46%, where the permissible limit is way below 0.1%. Now, for those outside the pharma world, DEG is not some poison. It's a common solvent used in antifreeze, brake fluids, and many industrial applications. But when it ends up in a child's cough syrup, it turns any medicine into poison. DEG causes acute kidney failure and, in most cases, death. It takes only a few milliliters to cause damage, and tragically, those most affected are often children. Unfortunately, this isn't an isolated tragedy. Sadly, these incidents aren't new. Several countries, including Gambia, Panama, Indonesia, and Uzbekistan, reported fatal incidents involving over-the-counter cough syrups for children contaminated with toxic levels of DEG and ethylene glycol EG. In Gambia, laboratory analysis revealed unacceptable levels of DEG in the syrups, products that ironically were imported from India. And this story repeats through history. Even India itself has faced earlier DEG-related tragedies, reminders that quality and testing must never be optional. Glycerin or glycerol is a common excipient, a pharmacologically inactive ingredient used to improve the texture, taste, and stability of medicines, making syrups palatable, especially important in pediatric drugs. It thickens liquid formulations and forms a soothing film on the throat, which is why it's used in cough syrups, lozenges, and even artificial tears. Most glycerol today is produced from the hydrolysis of fats and oils, and pharmaceutical grade glycerol today is derived as a byproduct of biofuels and oleochemical production. And here lies the problem. Diethylene glycol often enters in as a contaminant or adulterant because it shares similar physical properties, thick, sweet, and clear, and it is 3 times cheaper than glycerol. Sometimes it's accidental contamination from mislabeled drums or big human error. Other times it's intentional adulteration, a shortcut for profit that ends in tragedy. Economically motivated adulteration usually thrives where there is poor transparency, weak traceability, and limited quality control testing. And as this global incidents show, even a single bad batch can have international consequences. This isn't the first time. History has repeatedly shown us that the danger isn't in chemistry itself, but in neglecting control. 3 words sum up the problem: quality, oversight, and accountability. In some cases, manufacturers source raw glycerol from unverified suppliers, relying blindly on supplier certificates without analytical testing. Visually, DEG and glycerol look identical. It's colorless and a viscous liquids, but chemically they are so different. And one instrument can tell them apart reliably: gas chromatography. Most of the pharmacopoeial monographs, such as USP 467, have highlighted the use of gas chromatography with flame ionization detection (GCFID) using an internal standard peak response quantification method to detect the presence of EG and DEG in glycerol. They can track the presence of such impurities to part per million precisions. In simple terms, if every glycerol batch went through a routine GC screening, these tragedies could have been detected before the medicine ever reached a pharmacy shelf. But here's the bitter truth: the instrument can only raise a flag if samples are tested. Many small-scale pharma manufacturers operate under intense cost pressure with inadequate QC infrastructure or limited awareness of analytical testing. Regulatory audits often catch lapses after the product has already reached the market. To ensure such disaster never repeats, we need change, not in chemistry but in culture. Mandatory G, C, and GCMS screening for excipients like glycerol before use. Traceability of raw materials. Every barrel tracked from supplier to syrup. Capacity building for QC labs across small and mid-scale manufacturers. And international cooperation to standardize risk assessments and quality standards. Science can't fix negligence, but it can eliminate excuses. As we mourn the innocent lives lost, let's remember chemistry isn't to blame. Every chromatogram peak is more than data. Every chromatogram peak tells a story of purity, of responsibility, of lives safeguarded. And as scientists, regulators, and leaders, we owe it to society to never ignore a peak that really matters. And signing up for today, I'm your host, Dr. Manohar Rao, and this has been the science behind the recent cough syrup tragedy. Until we meet again, stay curious, stay vigilant, and above all, measure responsibly.